obviously with comparative vertebrate anatomy, one of the first things we want to look at are vertebrae. And so there's a lot of terminology associated with vertebrae which can make them a little confusing and a little intimidating at first. When we think about it, the vertebrae have two real purposes, a weight-bearing role and protecting the spinal cord, right? Which you know was created through normalation. When you look at a mammalian vertebra like this, there's so many parts to it, it's kind of hard to see the basic features. If we look at a more primitive vertebra like this one here, this being a tuna fish, we can see much more easily that we have a weight-bearing portion and a portion that protects the spinal cord. You can see that a little bit easily. What happens with other vertebrates that we don't see with fishes is to allow for different muscles to develop, we add all these projections that allow for muscle attachment. So it kind of obscures the basic features. But very simply, in the simplest form, we have a body, which is the weight-bearing portion called body or centrum. And then we have an arch that surrounds and protects the spinal cord called the vertebral arch, or since this is made up of nerve tissue, neural arch. You can call it either one. Those are the two basic components. By the way, see how this is tan in the center? That's not bone, that's the notochord. Remember how I told you in class yesterday they're like beads on a necklace? And here we see that central core being still a notochord right there. And what's kind of cool about these guys, each of these rings is like the ring on a tree. That tells you how old the tuna fish was when it died. We have something else here that we'll talk more about in a little bit, but this is the second arch that surrounds the blood vessels of the tail, called the hemoarch. Hemo referring to blood vessel. So here we have our arch and our body. The arch has a base, and that base is called pedicle. Peda, from the Latin word ped for foot. You stand on your feet, you're standing on the base of the arch. And then the sides of the arch, going up to the point, those are called lamina. So we have the pedicle and the lamina of the arch. This arch is going to extend forward to give us a nice spiky process. That's called the spinous process, also known as dorsal spinous process or even neural spine. So here's something that's different than a lot of your other classes. The lab practical is going to be fill in the blank. It's going to be in this room. When we've got a name like neural spine, spinous process, you use whichever one you want. It's easier for you to remember. Okay? If you can't remember whether it's EU or UE in neural spine, then spinous process might be the way to go, because spelling will count. But that's where you've got a little more flexibility, unlike with multiple choice where you have to know the way I remember it, which is a little unfair, but most of you won't be upset about not having points taken off for spelling on a multiple choice test. So let's take a look at this typical mammalian vertebrate, look at how we can take these parts a bit further. So here we see the body again, or centrum. This is all arch. Base of the arch is the pedicle. Sides and roof, lamina. Okay? Now remember, this is a three-dimensional thing. So on the lab practical, even if your book shows it to you like this, there's no reason why I can't turn it around and ask you what this part of the arch is from this point of view, or this point of view. That's why it's so important you work in the lab. You can look at the pictures anywhere, but in the lab's the only time you're actually going to be able to work with the real stuff, pick it up, look at it from different directions, say, well, that twisted bastard hanging upside down from the ceiling. No, he's too short to reach there. You know, you'll want to look at this from a number of directions to make sure you really know it. But base again, pedicle, sides, lamina, and of course here we have that spine coming off the lamina, so that's our spinous process. That's what you feel along your own back, right? So we have other processes here too. The pair of processes coming out to the side, transverse, and of course that should remind you of transverse plane. In us, if I was this animal, it would be sitting like this, and so the transverse plane would be dividing my body into, in humans we call it a superior and an inferior portion. But of course, when we look at it, all other vertebrates, it's going to cross this way, dividing the animal into a cranial and caudal portion. Okay? So that's the transverse. The transverse process is for bone attachment, like in the rib cage, we see the ribs attaching here, but also for muscle attachment. So if you put your hands on the small of your back, you'll feel those columns of muscle right on the side of your spinous processes. They're attaching to the transverse processes there. All right. So that's an easy one. And then we have four other processes, two here and two back here. These processes allow one vertebra to attach to another one. And you know the anatomical term for attach is articulate. So here's one articulating process pair. Here's another one. Now let's take a look at these where we got two vertebrae together. Okay? Here, by the way, is a notochord again. So here we see one articulating process and another articulating process from the other vertebra. The one that's articulating with the vertebra behind it is the caudal articulating process. The one that articulates with the one closer to the head is cranial articulating. So what we're going to see happening is, let's get back to pointing so my fingers don't block things. The cranial articulating process of this vertebra is going to be attaching to the, caudal articulating process of this vertebra is going to be attaching to the cranial one of the next vertebra. And then this one's caudal articulating process is going to attach with the next vertebra's cranial. So we're going to see caudal to cranial, or cranial to caudal, depending on how you want to focus. So here we have our caudal articulating processes, cranial articulating processes. And you'll notice that on the process, we have a smooth area. And that allows for the two bones to match up more closely with each other. I'm probably holding it so you can't see it, I'm sorry. The smooth areas allow the two bones to line up with each other more easily. So on the cranial articulating process here, we have a smooth area called cranial articulating surface. Guess what we call the smooth area on the caudal articulating process back here? It's not that hard. Caudal articulating surface, right? All right, so it's hard to tell vertebra when you look at them which end is up. It's kind of easy in humans because the way we walk so weird, all our spine processes point down. But you'll notice with this guy here, that's not always the case. But the easy way to tell cranial from caudal is the articulating process. If the surface is up, it's cranial, heads up. If the surface is down, it's caudal. Just like people's butt sagging when they get older. It's all in your future. So when we look at this guy here now, can you tell which side is cranial and which side is caudal? Right there, right? Surface up, so cranial and caudal. All right, so that's the basic features of the vertebra. And that's kind of where you want to go with, first of all. Once you know the basic features, you can see how they differ to understand regional differences. And